In this video, we are going to see 6.2 question. Use Lenz law to determine the direction of the induced current in the situation described by the figure. To apply the right-hand rule to Lenz law, first determine whether the magnetic field through the loop is increasing or decreasing. Here, the uniform magnetic field lines are represented by crosses. In this uniform magnetic field, it is given ABCD area. This magnetic field area is increased from this figure to this circular level. Okay, so now the magnetic field is increased. This crosses are magnetic field lines. Its meaning is magnetic field lines are inward direction. Okay, it's like this. It's moving inward direction. We already said like that magnetic field is increasing, then the direction of the induced magnetic field vector will be in the opposite direction, that is outward direction, like this. So this is the induced magnetic field. Okay. So next, align your thumb in the direction of the induced magnetic field and curl your fingers like this. So the curled fingers shows anti-clockwise direction. So the induced current direction is anti-clockwise. It is ADCB. So this is the answer. So this is the uniform magnetic field lines. These are represented by dotted lines. Its meaning is, its direction is outward direction. Then it is given a circular loop, that is ABCD, being deformed into a narrow straight wire, that is A prime, B prime, C prime, D prime. Here we have to find out the induced current direction. So for that we have to apply the right-hand rule to Lenz law. So it is clearly showing that area of loop is decreasing. So that the induced magnetic field vector will occur in the same direction to replace the original magnetic field's decrease, like this. So this is the induced magnetic field direction. Next, you have to keep your right hand thumb in the direction of the induced magnetic field and curl your fingers. Here the curled fingers clearly showing that induced current direction is anti-clockwise direction, that is A prime, D prime, C prime, B prime. I hope you understand the concept very well. Thank you for watching.